Hey guys, I wanted to make a quick video about going over some mole calculations practice problems. You have this worksheet that you're going to need to do, and I just wanted to go over a few more just in case you need the extra help. Here's some information we need to be aware of when we are doing these calculations. First of all, we have our T-chart set up. That is very important, okay? So we need to understand how to set up a T-chart. We need to know that our given goes right here. We need to know that we need units that match the given down there, and we need to know that our goal units are going to go up here. This yellow section, that's where we're putting our conversion factor every single time. And the two conversion factors that we need to know are down here, okay? These are our two conversion factors. Avogadro's number tells us how many particles are in a mole. And remember that by particles, we can mean atoms or we can mean molecules. We can mean either of those things by particles. And that tells us that there's this many atoms or molecules in a mole of any substance. And then we have our molar mass, and our molar mass tells us how many grams of a substance are in 1 mole of that substance. And the way we find that molar mass is on the periodic table. So the atomic mass of any element, so if we just look at sodium, this is the atomic mass of sodium. That tells us that there are 22.99 grams in 1 mole of sodium. Okay, that's really important information that we need to know to solve problems. So let's take a look at one of these examples. So I'm going to do number 2. So I want to know how many moles would be. So how many moles would be in 3.01 times 10 to the 22nd molecules of sugar. And it does give us the chemical formula of sugar right over there, but we may or may not need to use that to solve this problem. So I'm going to go ahead and set up a T-chart. Okay, and we know that our given is going to go in this first box. So our given is right here, 3.01 times 10 to the 22nd molecules. And I am going to write out that full unit. So 3.01 times 10 to the 22nd molecules. So remember, based on our T-chart, we know that our units that match the given are going to have to go on the bottom of our next section. So since we have molecules right here, we need to make sure that whatever we put on bottom is also going to be molecules. And on the top of our T-chart, remember, is going to be whatever our goal units are. That's whatever we're trying to find. And in this example, I pointed out to you that we're looking for moles. So we need to know that we put moles at the top of the T-chart in the conversion factor section. So now what we need to do is find our conversion factor. What is our conversion factor that we're going to need to use to solve this? We need one that tells us how many moles are in, or how many moles are equal to how many molecules. That's the conversion factor we need between moles and molecules. So if we look at our options, we have Avogadro's number or molar mass, and it looks like that molecules and moles are both involved in our Avogadro's number conversion factor. So that's the one that we're going to be using. So Avogadro's number says that 1 mole is equal to 6.02 times 10 to the 23rd particles. And in this case, our particles are going to be molecules. So we're going to fill those numbers in like this. 1 mole is going to be equal to 6.02 times 10 to the 23rd molecules. So that 6.02 is going to go on the bottom in this example. So next and only last final step is just to multiply across the top and divide by the bottom. So remember that when we're typing these in our calculator, we need to be really careful about using parentheses. So if I were going to type this into a calculator, this is exactly how I would do that. I would say parentheses 3.01 times 10 to the 22nd. I would technically multiply that by 1, but that's just going to give us the same number. So we're going to divide by this 6.02, and we're going to put that in parentheses also. Okay, so parentheses around those whole numbers. Type that into our calculator. And when we do that, let's see what we get. 3.01 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. The answer we get when we type that in, hopefully you get 0.05. And since our goal units were moles, our end units will be moles. So 0.05 moles is the answer to that question. So that's an example of using Avogadro's number. Let's look at another one. Just so you know, number 5 here, all you're doing is calculating the molar mass. So remember, molar mass is going to be how many grams are in 1 mole of a substance. So we're just looking at, we're just going to have to use the periodic table to figure that out. So if we have NaCl, what we're going to do is take the atomic mass of Na, which we just a second ago said was 22.99, and we're going to add that to whatever the atomic mass of chlorine is. I'll go ahead and look that up for you. So chlorine is 35.45. So we're going to add that in here. And all we have to do is add those two numbers together, and that would be our total molar mass for NaCl, okay? They get a little bit more complicated. Don't forget that when you have that, the parentheses and that 2 is going to distribute. So we would have 2 oxygens and 2 hydrogens in that example. So whatever your mass for calcium is, you'd have to add that to your mass for oxygen, but it's going to have to be multiplied by 2, and your mass for hydrogen is also going to be multiplied by 2. And you would add all of those up together to get your molar mass, okay? So those aren't too hard. It's just kind of adding together, okay? But let's take a look at number 7. So I'm going to do number 7 for you. So number 7 says, what is the mass? So we're looking for mass of 6.7 moles of magnesium. So it looks like that's our given right there. I'm going to go ahead and start setting that up. So our given is 6.7 moles of magnesium. And our goal units are mass. So we're looking for mass, and mass is not a unit. So we have to remember that mass is measured in grams. So that means our goal unit is going to be grams of some kind. And so once again, remember that these units have to match on the bottom. So our conversion factor that we're going to need to go in this box right here is going to have to tell us how many grams are in a mole of magnesium. So immediately when we are looking for grams, we should always relate that to molar mass. Anything to do with grams is always going to need, we're always going to need that molar mass. So since we are looking at moles of magnesium, we're going to have to look for magnesium on the periodic table. There it is right there. So magnesium has a molar mass of 24.31. So that means that there are 24.31 grams in 1 mole of magnesium. So that's our conversion factor we're going to need to use. So we just need to match up those units where they belong. Since grams are on top, we're going to put our 24.31 on top and our 1 mole on bottom. So for this example, we're going to take our number of moles, which is 6.7. So 6.7 moles and we're going to times that by our 24.31 grams. And when we do that, we can show that those units cancel out, moles cancel out, and we're only left with grams as our answer. So if we type that in, 6.7 times 24.31, that is going to give us 162.8. We'll round that a little bit. And so those goal units are grams, so that is going to be grams. So when it says, what is the mass? We're looking for mass. Our answer is always going to be in grams. So that's an example using molar mass and an example using Avogadro's number. So the only other one that I'm going to go over with you is a two-step T-chart question. So I'm going to choose number 11. We're going to do number 11 together. And that's actually just kidding. We're going to do number 12. We're going to do number 12, and I'll show you why we're going to do number 12. So this says a sample of carbon dioxide has a mass of 0.5 grams. So we have a number there for our given, and we want to know how many molecules. So our goal is molecules of carbon dioxide are in this sample. So carbon dioxide is what we're dealing with, and hopefully we can remember how to write the formula for carbon dioxide. So remember, this is a covalent compound, which means we have a metal, a non-metal and a non-metal. So we have carbon and oxygen. And since we have this di in front of the oxygen, that does mean that we have two oxygens. So the chemical formula that we're using is CO2, and that is going to matter in this example. So we have a sample of carbon dioxide with a mass of 0.5 grams. So I'm going to go ahead and start setting up this T-chart. 0.5 grams is my given. And we want to know how many molecules of carbon dioxide are in this sample. So since we're figuring out molecules, we know that we're going to have to use Avogadro's number. So we know that. So if we want to get to molecules, we have to use Avogadro's number. But the problem is, for this conversion factor, we're going from moles to molecules. And in our question, we are given grams. So what that means is, for this example, we're actually going to end up with two steps to the calculation. And let me show you what that's going to look like. So remember, grams is what we're starting with. So that means we need to cancel out grams by putting them down here. Okay. And like I said earlier, if we have grams, we need to immediately always think molar mass. So molar mass and grams always go together. So we need to know our number of grams of our molar mass of carbon dioxide. So carbon dioxide, we said, is CO2. So I'm just going to come over here and use this space over here to calculate that molar mass. So that means we have a carbon and we have an oxygen, and we actually have two oxygens. So don't forget that. So carbon, if we look up on our periodic table, molar mass of 12.01. And oxygen on our periodic table is 16.0. But remember that we have two oxygens, so that means that's going to have to times by 2, which gives us a total of 32. So that means altogether we have 12.01 plus 32. That's going to give us 44.01 grams for our molar mass of CO2. So that means in 1 mole of carbon dioxide, we have 44.01 grams. So since our grams are on the bottom, that number is going to go on the bottom. So what's going to go on the top here? Well, remember, this is still a conversion factor. This step of the chart is a conversion factor. So what we just did, this calculation, like I said, tells us that there are 44.01 grams in 1 mole of CO2. That's what that number is telling us. So that's why 1 mole is going to end up going on the top. So right now I can show you that our grams cancel out, so that's exactly what we want. But our goal unit is molecules. Remember, we're trying to figure out molecules, and right now if we stopped, we have number of moles. So what we have to do is go from moles to molecules now. So since moles are on the top, as of right now, I need to make sure that I put moles on the bottom of my T-chart so that they're going to cancel out. And now I can put my goal unit, which is molecules, on the top up here. And what we see now is that we need a conversion factor, a second conversion factor that tells us how many molecules are in a mole. And that is something we know. We know that there are always going to be 6.02 times 10 to the 23rd molecules in a mole. So I'm going to fill that in. 6.02 times 10 to the 23rd molecules are in 1 mole. And I can see now that my units for moles cancel out and we're left with molecules, which was our original goal. So this is set up completely correctly, and all we have to do is multiply across the top and divide by the bottom. So I'm running out of room a little bit here. Let me add another page. Okay, so we have 0.5 times 1 times Avogadro's number, and then we're going to divide by 44.01 and divide by 1. So here's what that looks like in our calculator. 0.5 times 6.02 times 10 to the 23rd divided by 44.01. We could multiply by 1 and divide by 1, but remember, that's not really going to change anything. So if we type this directly into our calculator as we see it, we should get an answer of 6.84 times 10 to the 21st, and our goal units were molecules. So that is how many molecules would be in 0.5 grams of carbon dioxide. And that is how you solve a two-step mole calculation. So that's all the ones I'm going to go over in this video, but of course, send me an email. If you have more questions, I'll be happy to answer them and maybe even work with you on a few more if that's what you need. All right, so I'm here for whatever you need. Just let me know. Hopefully this helped.